Hey kiddos, so today we are going to talk about chords in specific and circles. Okay, so remember, a chord is a segment with endpoints on the circumference of the circle. Okay, so let's talk about chords and arcs. Special relationship about particular chords and their arcs. In a circle or congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So therefore, if you can notice here in our picture, chord AB and chord CD are marked as congruent. So therefore, what that justifies to us is that arc AB would be congruent to arc CD. So these two arcs measurements would be congruent since their chords are congruent. So let's look at an example. So first example here, notice I've went ahead and made some markings here. Chord WX is 46 and chord YZ is also 46. So notice I marked them as congruent, they're both 46. Then it tells the measurement of arc WX is 82 degrees. What is the measurement of arc YZ? Now, because our two chords are congruent, we can conclude that these two arcs would have to be congruent. So that would mean that the measurement of arc YZ has to also be 82. Oh, and sorry, I didn't mean to say or write degrees. Sorry. All right, so now let's talk about chords being perpendicular to a radius or even chords being perpendicular to a diameter. What happens? So in a circle, if a diameter or the radius, okay, is perpendicular, which hopefully we already know perpendicular means that it creates that 90-degree angle, okay, to a chord, then it bisects, create two congruent parts, the chord and its arc. So in this example here of this circle, we can see that we have a diameter here of BA. BA is the diameter. Okay, and we can see that we have the chord here of TV, all right? And they are perpendicular, which we can see noted right here because I see that 90 degrees there. So then that means that chord is bisected, which you can see I already marked. So we can write that TX is going to be congruent to VX. And not only that, but the arcs are also going to be considered congruent. So we have arc TA is congruent to arc VA. All right, so now let's look at an example here. So we are given that chord AB, okay, is 60. And we're also told that the measurement of arc AB is 142. We can also clearly see that we have a radius. XC is the radius for this circle because it goes through the center to the circumference. All right. So we can also note that the radius and the chord are perpendicular to each other. So that tells us a few special things that happen to the chord and its arc. The chord is bisected, and as well is the arc. So let us find these values. Since the chord AB is 60, and I know that it is being bisected by the radius, then I know that AD would be half of 60, which would lead us to conclude that it's 30, which would also mean then that BD would have to also be the same because they're congruent. And for the arc, we are told that the arc AB is 142. And because a chord is perpendicular to the radius, it bisects this arc, which means 142 divided by 2 leads us to conclude that the measurement of arc AC is 71, and so is the measurement of arc BC. They're both going to be 71. All right, so far so good, I hope. And moving to the last concept about chords, okay? Chords being basically equidistant to the center. So, in a circle, or congruent circles, two chords are congruent if and only if they are equidistant from the center. So, as you can see here in our picture, we have chord BA and chord DE. Now, the reason why I know that they're equal distance to each other is because of this right here. CX, the segment CX, is congruent to segment CY because they're marked as so, which would tell us then that these two chords would have to be, you said it, congruent. So, because of that, so since segment CX is congruent to segment CY, therefore chord BA is congruent to chord DE. So, let us look at an example. All right, so this example states that we have PX and MX, and they are equal to 10. So I went ahead and put 10 here. 10's already there for us. And then they tell us that the radius, XY, is 26. Hopefully you guys are noticing that XP or XM are not radii because they don't go all the way to the circumference. Okay, so make sure you understand the difference there. So XY is the only radius given in this problem. We have chords WV and chords YZ, and those are the measurements that we're looking for. But I also added another part to this, so be sure you do that, to find the length of YM. Okay, so let's get to it. So the question is where to start then? Well, we're going to have to use some prior knowledge or knowledge on our right triangles to actually get us started. So in order to figure this out, we actually need to figure out what YM is, okay? And we can figure out what YM is by using Pythagorean theorem because we see that this is a right triangle. So I redrew the picture just so you guys can see it a little bit clearer. And we're going to be using Pythagorean theorem. Now be careful because we're given the C value and an A value or B value, wherever you want to put that. But we're given the C value, okay? So be cautious of that when we work this out. So when I plug this into Pythagorean theorem, we get 10 squared plus b squared equals 26 squared. So that's 100 plus b squared equals 676. Subtract 100 to both sides. You end up with 576, which hopefully you know is clearly not our answer because we need to do one step more, and that is to take the square root of it. And when you take the square root of 576, you end up with 24. So YM, oops, I didn't mean to move that. YM is 24. So YM is 24. Now, we have already, or I have already mentioned that XM is not technically a radius, okay? But if we were to continue that line, okay, and actually make XM go all the way to the circumference, because it goes through the center, it would be considered a radius, okay? It's not here technically, but if we were to make an extension of the line, it would be, which would lead us to our previous example that when you have a chord, okay, that is perpendicular with a radius, then that would mean that that chord is being bisected. It's going to be two equal parts. So therefore, if YM is 24, then ZM must also be 24. So we know that chord YZ is equal to 24 plus 24 leads us to 48. So now we just got to figure out what WV is. Now, before you just say, oh, well, it's congruent, Okay, you have to have justification. Now, the reason we can establish that WV, that chord, is congruent to chord YZ is because these two chords are equal distance from the center, because XM is 10 and XP is 10. So because of that, WV has to also be congruent to YZ. So therefore, they are both 48. Kudos, kudos.